Many Cambridge A-level students struggle with calculations, not because they don't know formulas, but because they misunderstand physical quantities and units. With over 7 years of teaching experience, I'm going to break this topic down step by step so you can solve questions accurately and confidently. We begin with paper 2-1, May-June 2024. The drag force acting on an object falling through A is given by AD equal to 1 over 2 C rho AV squared, where A is the cross-sectional area of the object, V is the velocity of the object in the air, rho is the density of the air, and C is a constant called the drag coefficient. Use SI based units to show that the drag coefficient has no units. Now, first, you make C the subjects of the formula. C equals to 2md over rho A V squared. For you to get the marks, you must write out the units for each of them. When you are looking for SI base unit, constant don't contribute to base units. So 2 will not contribute to base units. For force, we have kilogram meter per second squared divided by kilogram per meter cube times meter squared times meter per second all squared. This is 1 mark. You expand it. This is the second mark. Now you cancel each of them out. Now S minus 2 will cancel minus 2. M, one of them will cancel one of them. And this will cancel this. You write 1. Finally, you write C as no unit. That is how to get the mark. Number 2, figure 1.1 shows a sphere falling at terminal velocity in air. Assume that the obtuse on the sphere is negligible. On figure 1.1, draw and label arrows to show the directions of the two forces acting on the sphere. This is another question. The key point A is terminal velocity, meaning upward force equal to downward force. For you to show it well, your arrow down for the weight must be equal to your arrow up for the drag force. That is how to get the answer. Calculate the drag force acting on the sphere. So weight equal to drag force. The mass of the sphere is 49 grams. So drag force will now be equal to mg, which is 49 grams divided by 1000 to change it to kilogram times 9.81. And the answer will give us 0.48 Newton. That is how to go about it. The next question. The sphere is falling in air at a terminal velocity of 25 in SI base units. The density of the air is 1.2 in SI base units. The diameter of the sphere is 0.06 in SI base units. Use your answer in C to calculate the drag coefficient C for the sphere. So we use the formula that was given to us, F equal to 1 over 2 C rho AV squared, to find it. I'm going to show you where students miss mark. So if we have 1 over 2 C rho A V squared. Now, this is where students miss mark. This diameter of a sphere. Some students don't know the area of a sphere. Here, so the area will be taken as pi radius squared or pi d squared over 4 because this shows as a circle. That is where students missed. C equal to 2mg over rho A V squared 2 times 0.48 divided by 1.2 times area area is equal to pi radius square. So radius, we divide 0.06 by 2 and all square. So this gives us 1 times pi times 0.03 squared times 25 squared. And that will give us 0.45. Where student miss is mostly the area they miss it there. I believe you will not miss it. Next question. We look at May June paper 22 2023. The first question, define pressure. Pressure is force applied perpendicular to the surface of an object, the unit area. Use the answer to AI to show that the SI base units of pressure are kilogram per meter per second squared. You say pressure equal to force over area. Unit for force is kilogram meter per second squared. You can get it from mass times acceleration. And here is meter squared. One will take one, leaving behind kilogram per meter per, per second. Next question. A horizontal pipe has length L and a circular cross-section of radius R. A liquid of density flows through the pipe. The mass m of liquid flowing through the pipe in time t is given by m equal to this, where P1 and P2 are the pressure at the ends of the pipe and K is a constant. Determine the SI base units of K. Change in pressure will not change the units. The units will be the same. Only the magnitude will change. So pressure that we got was kilogram per meter per second squared. That will not change in any way. Density will be kilogram per meter cube. Radius, r squared fourth will be m raised to the power of 4. Length will be m and time will be second. Let's put everything here as we make k the subject of the formula. So we have k equal to change in pressure r raised to the power of 4 density T over L and M. You notice that I didn't include pi and 8 because they are constant. They don't contribute to base units. We substitute the values kilogram per meter per second squared times meter raised to the power of 4 times kilogram m minus 3 times s divided by m times kg. So we cancel them one by one. This takes one of these. This will take one of these. Remaining 3. So the 3 will cancel the minus 3. So we have kilogram per meter per second. Try to ensure that you get it right. An experiment is performed to determine the value of K by measuring the values of the other quantities in the equation in B. The values of L and R each have a percentage uncertainty of 2%. State and explain quantitatively which of these two quantities contributes more to the percentage uncertainty in the calculated value of K. Now, looking at the equation, we have P r raised to the power of 4 and we have L, just L value. The uncertainty in R will be more because R will give 4 uncertainty of R percent. So that will be 4 times 2, which is 8%. Whereas L you will only contribute 2%. So R will contribute more. Why? Because it is to the power of 4. So it will be 4 times 2, which is 8. Let's go to paper 2 to major in 2018. What is force? Force is the rate of change of momentum. Rate of change of momentum. The unit for force F equal to MA, which is kilogram meter per second squared. The force F between 2 point charges is given by F equal to Q1 Q2 over 4 pi R squared epsilon. Use the above expression to determine the base unit of epsilon. So we make epsilon the subject of the formula. So have Q1 Q2 divided by F times R squared times 4 pi. The 4 pi will not come in because they don't have any units. First, write out what each of them has as units, SI base units. So we have this. So let's put it. Now this will give us AS for Q1 times AS for Q2. Remember Q is charge. Charge is current times time. Divided by kgms minus 2 times m squared. This gives us a squared s 2 kg m3 s minus 2. This will give us a squared s 4 kg minus 1 and m minus 3. That will be the answer. Check your own to be sure that you can get that as well. Okay, let's get to the next question. This is paper 2 to October November 2016. So the first question, pressure, we have done this one. Show that pressure is kg m minus 1 s minus 2. We have done this. So let's get to the next one. Gas flows through the narrow end nozzle of the pipe. Under certain conditions, the mass m of gas that flows through the nozzle in a short time t is given by m over t equal to kc square root of rho p, where k is a constant with no unit. C is a quantity that depends on the nozzle. Rho is the density of the gas arriving at the nozzle. P is the pressure of the gas arriving at the nozzle. Determine the base units of C. We make C the subject of the formula, and we have that is m over t divided by square root of rho p and k. So k has no unit. Rho is kilogram per meter cube. P is kilogram that we had m minus 1 s minus 2. Mass is kilogram and t is seconds. We put it there. C will be equal to, this will give us kg s minus 1. Looking under it, you have something like kg squared m minus 4 s minus 2. Removing the brackets, we have kg s minus 1. Square root affects the square. So this will give us kg m minus 2 s minus 1. Kg cancel kg, s minus 1 cancel s minus 1. Remaining 1 divided by m minus 2. And that gives us m raised to the power of 2. Kindly do it. Let me know your answer. This is paper 2-3, October, November 2015. Paper 2-3, October, November 2015. The intensity of a progressive wave is defined as the average power transmitted through a surface per unit area. Show that the SI base units of intensity are kgs minus 3. The first thing, they gave us what the intensity is, that is average power over area. So we need to know what power is. Power can be work done over time, and work is force times distance over time. If you forget the power or the SI base units of any, you can quickly get it somewhere. We have kilogram m raised to the power of 2 s minus 3 divided by m squared. This cancel this, and that will give us kilogram per second cube. The next question, the intensity I of a sound wave is related to the amplitude x naught of the wave by the formula. Show that k has no units. K basically will be I divided by rho c f squared x naught squared. So what are the units? We have I already as kg is minus 3. Density kilogram m minus 3. Speed meter per second. Frequency is 1 over period, so that would be s minus 1. Amplitude is maximum displacement, that will be m. So let's substitute it. We have this m minus 3 times c m s minus 1 times s minus 1 all squared times m all squared. The examiner expects you to write out this before you can get the mark. Remember, this work is to help you get your maximum mark. That is why I'm spending time to do this. Once the examiner sees this, you cancel these two, this goes equal to 1. You now write K as no unit. If you don't break it down, you will not get the mark. The next question, calculate the intensity in PWM minus 2 of a sound wave wey K 20 they give us. So we take it to the formula that was given to us. The formula we got I equal to K density C F squared X naught squared. You substitute the values 20 times 1.2 times 330 times 260 all squared times this is where students makes this most students failed at this point. What does n stand for? N stand for nanometer. N is 10 to the power of minus 9. This is where most students missed. So you have 0.24 times 10 to the power of minus 9 all squared. That is where most students miss. And the answer will give you 3.08 times 10 raised to the power of minus 11. Another place student miss is where I'm going to show you. Now, if you have this, the answer was to leave it in P W n minus 3, n minus 2. What does P stand for? P is the same thing as 10 to the power of minus 12. So we will change this to something of minus 12. That will give us 30.8 times 10 to the power of minus 12. This and this. So we now replace 10 to the power of minus 12 with P. And we have our final answer as 80.8 P WM minus 2. Our answer will be 80.8. We come to the end of today's deep and step-by-step revision. Check my next video to see another steps you are to do to avoid mistakes and to get maximum marks. See you in our next video.